Section 6.4, we are going to find the derivatives of log functions and natural log functions. So, one piece of information that you are going to be given is that the derivative of the natural log of x is 1 over x. Okay? 100% of the time, the derivative of natural log of x is 1 over x. Given information. Now, actually, the derivative of the natural log of x is 1 over that thing in parentheses times the derivative of the thing in the parentheses. And the derivative of this thing in parentheses is a 1, so we get 1 over x. Now, another way to write this is the derivative of natural log, derivative of the natural log of something. Probably the most efficient way of writing this is equal to the derivative of the something divided by the something. So, if I'm going to find the derivative of the natural log of 3x squared minus 5x, the 3x squared minus 5x is the something. So to find the derivative of that, I'm going to find the derivative of the something, which is going to be 6x minus 5. That's the derivative of the something divided by the something. And that is how you are going to find the derivative of the natural log of absolutely anything. Derivative of the something divided by the something. Now, what if we have an log log? We want to find the derivative of an log log base a of x. Well, that, again, more given information here. The derivative of that is equal to 1 over x. But now we throw in this something a little different here. We throw in that we're multiplying the bottom by the natural log of whatever the base is. So what if we wanted the derivative of the log base 4 of 3x squared minus 5x? We're going to do the exact same thing we did over here. The exact same thing we did over here. Since this thing in parentheses isn't just a plain old x like it was up here, I'm going to take the derivative of the something I'm going to divide it by the something. But because the base is something other than e, the base is something other than e, what I've got to do is I've got to multiply the bottom by the natural log of that base. So the derivatives of natural logs and the derivatives of log logs are really done the same way. Except with an log log, I got to remember to multiply the bottom by the natural log of the base. But otherwise, it's just derivative of the something divided by the something. Now you may say, oh, geez, why are these different rules, whether I'm talking logs or natural logs? Well, what if I applied this rule of logs with this natural log thing down here? What if I applied that to this guy over here? I would still take derivative of the something divided by the something, but I'd have to multiply this by the natural log of the base. And the base of a natural log is e. And so this just has a value of 1, which is why I'm not including that. So the derivative of a natural log is the natural log, or is the derivative of the something divided by the something. And the derivative of an log log is the derivative of the something divided by the something times the natural log of the base. Logarithmic differentiation. Now this is a pain. We're only going to use this if you are asked specifically to use logarithmic differentiation. You never, ever, ever use it at any other time. And it is a three-step process where if you're told to use logarithmic differentiation, you take the natural log of both sides, differentiate implicitly. We'll see what that means shortly. And then solve for y prime. We've got to get the y primed all by itself. All right. So y is equal to x cubed over 4x squared minus 3 to the fifth. Now we could quotient rule this, but we are told to use the method of logarithmic differentiation to find y prime. So step one is to take the natural log of both sides, and the natural log of y is equal to the natural log of this x cubed over 4x squared minus 3 to the fifth power. Now, before I jump in and start taking the derivative, I'm going to say that the natural log of y is equal to, I'm looking at stuff over here that is being divided. I'm going to say I could rewrite this as the natural log of x cubed minus the natural log of 4x squared minus 3 to the fifth. Just using our laws of logs that we talked about in section 6.3. I'm even going to go a step further and say the natural log of y is equal to, what am I allowed to do with this exponent? 3 natural log of x. Minus, what am I allowed to do with this exponent? 5 natural log of 4x squared minus 3. Now I'm going to take the derivative. And I've done this first step. I've taken the natural log of both sides, and I've simplified that one side quite a bit. Because now it's going to be much easier to take the derivative of that side. But before I take the derivative of what I see over here on the right, I'm going to find the derivative of what I see on the left. And the derivative of the natural log of something is the derivative of the something divided by the something. The derivative of y is called y prime. The something in this case is y. Now I need the derivative of 3 natural logs of x. 3, come along for the ride. And now I've got to have the derivative of natural log of x, which is the derivative of the something over the something. Minus 5, you are a coefficient, come along for the ride. I need the derivative of natural log of this thing. So I'm going to take the derivative of that something, which is 8x, divided by the something, which is 4x squared minus 3. Okay, awesome. I have taken the derivative of both sides. Now I've got to solve for y primed. And what I'm going to do is I'm just going to multiply both sides by y. And that's going to leave me with y primed equals. Now I'm just going to clean this up a little bit. I'm going to call this thing 3 over x. minus this guy. Probably call that 40x over 4x squared minus 3. And I'm very tempted to write times y. Y primed can't have y's in it. Instead of writing y, what I'm going to write is what y is equal to. I want my derivative to be in terms of x's. So instead of writing times y, I'm going to write times x cubed over 4x squared minus 3 to the fifth. And then I'm done. I don't have to distribute. I don't have to simplify. I don't have to do any of that. This is what y primed is equal to. You may leave it like that. That's the method of logarithmic differentiation. The answer looks a little different than it would be if you actually used the quotient rule on this thing. But at any x value, you're going to get the same slope if you found derivative using quotient rule or if you found derivative using logarithmic differentiation.